ಸ್ವಲ್ಪ ಇಲ್ಲಿ ಆಯಿತು, ಲೆಟ್ ಎ ಮಿನಿಟ್. Check that one. Smaller. Yeah. Now, okay. Still smaller. Adjustment of screen is a problem. Time. Okay. Reasonable, okay? Voice and screen, both are okay? Voice and screen, both are okay? I think both are no problem, I think. Both voice and screen. Up to there I can write. Okay. Okay, start. So, make a heading. See, limited option, not too much, because overhanging means all. You can solve easily by Macaulay's method. You don't have struggle, but it is very useful for competitive examinations and to understand. But when you cover a subject, we should cover everything. See, right heading there. Conjugate beam method for beams, simply supported beams with overhangs. With overhang or overhangs. With overhang. Now, not much difference. One small minute part. See, real beam, I will tell end condition or support condition in real beam. Then corresponding in conjugate beam. I already told you, see, simple support in real beam will be simple support in conjugate beam. Therefore, if a simply supported beam is there, it will become simply supported beam here also. Correct? Tell me, clear? If a simply supported beam is in real beam, conjugate beam also, it will be simply supported beam. Okay, now, next come to cantilever. Cantilever. Fixed end in real beam will become free end in fixed end in real beam becomes free end in conjugate beam. Whereas free end in what? Real beam becomes fixed end in conjugate beam. Therefore, see, if the cantilever is like this, conjugate beam will become like this. Whereas if the cantilever is like this, see, conjugate beam will become like this. This also clear? This already over. This also clear? For now, lastly, overhanging beam. This also clear. Okay, now, lastly, when you got overhanging beam, be careful. See, I'll put here. What happens is, see, very important, overhanging support in real beam will become internal hinge in conjugate beam. Tell the reason. See, suppose there is a overhang is there. Deflection should be 0. but slope is there. We can't put simple support because if we put simple support, we can't continue the beam. Therefore, overhanging beam in what? See, one more thing. By chance, you put simple support. When overhang comes there, the shear force will be different on either side. So that will change that will give problem. See, here, slope should be equal on both sides, but deflection 0. So bending moment should be 0 in conjugate beam. And shear force should have only one value. You cannot have two shear forces. Therefore, overhanging support in real beam becomes internal hinge in conjugate beam. This clear? Internal hinge means, see, I will put here. That is, see, if the B, see, suppose by chance you take here, simple support here, overhang here. I will tell A, B, C. Conjugate beam, what will happen? See, A is the end simple support. It will remain simple support only. Then, C is free end. It will become fixed end. B is overhanging support. That will become internal hinge. A, B, C. C. Simple support in real beam is simple support in conjugate beam. Free end in real beam equal to fixed end in conjugate beam. Overhanging support or interior support becomes internal hinge in conjugate beam. Or if the beam is like this, see, suppose there is a left overhang. See, one question I am solving when overhang is right side. One simultaneous question when overhang is left side. As I solve this one, I will tell that one. And today's class, the first question is very, very important for competitive examination because I am applying a trick. See, I got my own trick to solve any problem by mixing up the methods. Sometimes I give fast answer. I use all the methods. For something I use this method. For something I use that method. That trick I cannot tell. Sorry. That is beyond, sorry to tell, it is beyond the limit or capacity for ordinary people. Even those who understand, very difficult to reach there. So if I tell further, I will be boosting myself. So I don't want to tell. So my personal tricks, I can't divulge here. First of all, if I tell all those things, next class nobody will come. Hey, he talks nonsense, they will tell. But he talks some randomly, but answer comes. Or maybe he already solved. Somewhere there he put the answer sheet there. Looking there, he is telling the answer. People can comment that way also. Hey, he is telling something. Kannada, Yarraberry. And answer comes correct. We can't make out anything. So most probably, somewhere there, maybe in front of camera, he has put the answer. Come and check it here. Those who know me, they won't tell those things. Why? Offline calls also I do that one. But anyway, competitive examination, tricks are there. I will apply the trick today. I will tell what trick. You don't have to solve this way. Very easily, you can solve the question by tricks only, overhanging beam, if the load is on the overhang. This is a very popular question. See, a simply support beam with overhang, they give a load in the overhang. That's all. If the load is given here, then it becomes, then also tricks are there. Leave it, time being. Very popular. See, competitive examination. So many papers you can see, GATE or engineering service hall. They will put a load W here, ask you, what is the deflection at C? People who solve by Macaulay's method, they find reaction, take a section XX, then integrate 2 times, lengthy. Conjugate beam method, all this calculation, no, nothing. Just a simple trick will give the answer. I will tell the trick for you after I get the answer here. After I get the answer, I will tell you the trick. You understand the trick. Okay, now, see here. First question is here. Left is, see, my question I will give now. See, left simple support and right side overhang. My first question is here. So, what happens now? Left simple support will remain simple support. Right free end become fixed end. Interior support, overhanging support, internal hinge. Or, if the question is like this, that is your next question. Then, see, free end here will become fixed end here. Then, simple support, end simple support will remain simple support. Interior support or overhanging support becomes internal hinge here. A, B, C. Or by chance if double overhang is there, usually no. A, B, C, D, for example, okay, A, B, C, D. Then left is free end, that will become fixed end. Right is free end, that will become fixed end. Both are overhanging support. Double internal hinge. See, A, B, C, D. This is how we have to do it now. Clear? This is change of end conditions for conjugate beam. It is allowed to us. Internal hinge can rotate. Internal hinge can rotate very much, no problem. Internal hinge, but the bending, see, internal hinge can rotate. Yes, rotation is there here. That is nothing to worry. Clear? Okay, now, one very important, now, see, my first question is, I will tell you now only, later I will not tell. Left is simple support. I will put the question because here I have marked the reaction. This you see later. Left is simple support. Okay. It will remain, see, my first question I will tell here now. See, I will tell class question, class main question, and also simultaneous question you have to solve. Somewhat like exercise, or you can call homework. That is second question. Okay, see, I will tell the question by words now. There is a beam which is simply supported over a span of, see, simply supported, right this way, simply supported over a span of 5 meters. Don't see the solution there. For a span of 5 meters. Then it has a right overhang of 2.4 meter. It has right 2.4 because I want fraction 2.4 meter. ABC I will call ABC. Okay, then further. The beam is loaded by UDL of 20 kilonewton per meter on the overhanging side. 20 kilonewton per meter on the overhang. That's all. Find, see question, find slopes at supports, comma, slope and deflection at free end, that is at here, and also slope and free end, and also one more thing is there, deflection at center of the span. Center of the span. Random point can be given. So usually popularly center of the span. That is, see, span is here. Center of the span means not center of the beam. This is 5 meter, the central point deflection. So competitive examination, they can ask any one of this one. Each will take half minute. Not by conjugate beam method. By the tricks I am going to tell. Okay, now, second question I will tell now only, which is exercise. See, solution is already there. A beam, or I will give question by sketch only. For the beam shown in figure, I will put a point load here of 30 kilonewton. This length I will put 4 meter. This is 10 meter. I will call ABC here. For the beam shown in figure, find same thing. What? Slopes at the supports, same as this one, comma, slope and deflection at the free end A, load point, and also deflection at the center of BC. If they ask elsewhere, then you require it to work. Then tricks you can't apply. I can apply the trick, but you can't apply the trick. Okay. Second question. I will start this question. See, first question loaded by UDL. Therefore, parabola is coming. Second question, point load. So, triangle is coming. So, this parabola, you know, area equal to 1/3 base into height. Triangle, see, only overhanging side. Don't see inside. Overhang, inside same for both. For this parabola area, 1/3 base into height. For a triangle, area half base into height. CG for this parabola, from here 3/4, from here 1/4. Here you know it, 2/3, 1/3. So, if I solve this question, simultaneously, I will not give any hint. I will give the answer using the trick. Can you solve that question? If I solve first question, only change is what? Area 1/3 base into height, area half base into height. And CG at 1/4, 3/4, CG at 1/3, 2/3. And one more thing, interchanged. Can't see here. Internal hinge comes where? Internal hinge comes this side. That all I will tell you now simultaneously. Okay. Now I will start solution. First solution by conjugate beam method systematically. Then I will tell you shortcut. Okay. This all I will remove now. Now start the first question. Second question you start yourself only. First question. Our class question. First step is consider the real beam. We require bending moment diagram. Okay. For that, reaction calculation. This is for the real beam, not conjugate beam. So reaction we require. What you do? Show the beam shown in figure, what I told you just now, by words. It is again, when I want red color, I won't get red. When I want other color, then I am getting red. Okay. First question I told you, this is the beam. There is a simple support here. See, show this way. One more simple support here. And UDL is here. How much UDL? 20 kN per meter. I will name the beam as A, B, C. See, vertical, you write the support. See, this is simple support like that. Vertically upward reaction VA, vertically upward reaction VB. Actually, I am 100% sure that this reaction at A is not up. It is what? Tell me. It is guaranteed. When you have overhanging beam, if the span is not loaded, if the span is loaded something else, if you load only overhang, because of this load, support A will get lifted up. See, support A will get lifted up. So reaction here has to come down. Clear? Because if I am solving, I won't take upward. It has to come down. But anyway, systematic solving, take upward. Second question also do the same way. Okay, start. Take moment about A, any point. Or take moment about, okay, A only will do. Some meters are A only. Okay. Take moment about A. Clockwise positive. This is 5 meter. This is 2.4 meter. Minus VB into 5 plus 20 into 2.4 is the total load into 2.4 into what? No. See, space problem. Minus VB into 5 plus 20 into 2.4 is the total load into moment about A. 5 meter plus 2.4 by 2 equal to 0. Tell correctly VB value. Fast. VB value. Don't see the answer there. Don't see there. Do not see what I wrote on the board. You tell the answer. Do not see the board. Answer. VB value. 599. Yo. 599. Do you have a calculator? Which calculator are you using? Which is the calculator used? 59.52. Extra 9 printed. Okay. 59.52. VB will come plus 59.52 kilonewton. Now see, this only will tell you VA down. Why? See, total load is 20 into 2.4. 20 into 2.4 is 48 kilonewton. Already reaction came 59. To balance, it has to come down. Anyway, calculate. Plus came. Sigma V0 take upward positive. Plus VA plus VB minus 20 into 2.4 equal to 0. Tell me the value of VA. Substitute VB equal to 59.52. Correctly with sign you have to calculate. When you calculate, how much VA will come? I am 100% sure it will come negative. How much? First of all, those who are coming to deflection class, if they do not know how to find support reaction, it is not worth for them to come to the class. Why? Such a elementary knowledge. VA minus 11.52. Okay, now do one thing. What all I tell right now. Now you start conjugate beam method. Okay. Neatly sketch the real beam. Okay, start. Here, you can see, you can show a support here if you want. This way support. Okay. Here, Reaction we got negative. So put downward of 11.52. Here you got upward 59.52, 5 meter, 2.4 meter. This is the real beam. Okay. Leave it. Time being tell, I will come to you later. Simultaneously start second question. I'll tell you why. Okay. Second question. Put the sketch neatly. There is a reaction here called VB, reaction here called VC. See, ABC problem is there. This is A, this is B, this is C. This is 4 meter, this is 10 meter. Load is 30 kilonewton. Sigma M, don't take moment about AY, you should take moment about support. Sigma M about B0, clockwise positive. See here. Minus VC into 10, again minus 30 into 4 equal to 0. Tell the VC value. Now you know that VC will come negative. Why? That will get lifted. Tell VC value. Fast. Tell the VC value. VC value. Fast. What is the value of VC? I will tell the trick after the question is completed. Very important for objective question. This is a very popular question for GATE, engineering service hall, because they will expect the trick only there. 1 mark question. So therefore, if you do all this way, you can't write the exam. I will tell the trick. Minus 12 kilonewton. Okay. Minus 12 kilonewton. Sigma V equal to 0, upward positive. Plus VB plus VC minus 30 equal to 0. Put to VC equal to minus 12. Your VB will come plus 42 kilonewton. Okay. Now, start the question. Neatly put the beam. This reaction you got negative. So what you do? Write downward reaction. VC equal to, how much you got? No minus now. 12. Why? We reversed. And right here, VA equal to, how much VA equal to? 42 kilonewton. Enter there. 10 meter. A go that side. 10 meter. Don't disturb me. 4 meter. Okay. 1 meter. I'll put once again. This is VB equal to 42 kilonewton. VC equal to down of 12 kilonewton. Okay. Now, ABC. This is the real beam. Both question up to here. Fully clear? Both, I am telling what? When they load the overhang for a beam, how very fast in competitive examination you can solve it. But for that, first we will apply conjugate beam method. Once you get the answer, last minute tricks. Okay, now draw BMD for both the beams. See, I will show the calculation here. Come to this question. Start. Bending moment calculation for real beam. See, using that, draw BMD for real beam, sagging positive. Start. BM at A equal to 0. Look that side. BM at B. I think better look this side. Minus 20 into 2.4 into 2.4 by 2 equal to, don't waste time, minus 57.6 kilonewton meter. Bending moment at C equal to 0. Or at B, if you look left side, it is minus 11.52 into 5, same value will come. Now draw BMD for real beam. Start. 0 here, 0 here, here 57.6, negative, so sign, usually we don't write downside, minus. Remember, sign required minus, this also minus. And remember, this is linear variation, this is parabola. And if I see BC portion, is it, see, now do one thing, decide whether you can apply the formula of area equal to 1/3 base into height and CG 1/3, 1/4 or 3/4, how you decide? See the BMD from 0 ordinate to maximum. Tell me, does it correctly match with the cantilever? Even though it is not a cantilever. See, cantilever means what? This is fixed. Even then, suppose I look this side, does this BMD is exactly matching with the cantilever BMD? Yes or no? Yes. Right. Therefore, area equal to 1/3 base into height, CG at 1/4 V4 is valid. Here, see. Now, second question. Okay, start. Second question. BM for this question. BM at A, 0. BM at B, look this side, minus 30 into 4 equal to minus 120. BM at C equal to 0. 0 here, 0 here, 120 here, negative. BMD for the real beam, sagging positive right there, over. Now, both question over. Here that question will not come by triangle. For triangle area is, see, now change is half 1/3 base into height, half base into height, CG 3/4 1/4, CG 2/3 1/3. This is triangle, this is also triangle. Okay, start. Now, next step is very important. Now draw BM by EI diagram. 0, 0, 57.6 by EI. And negative, so upward load, negative, upward load. Here also, 0, 0, 120 by EI, negative, upward load. This is the, right, BM by EI diagram. Below, sketch conjugate beam, very important. Below sketch conjugate beam. Now remember, you should write what all I tell you should write. Simple support in real beam will become simple support in conjugate beam. Over. Overhanging support in real beam, I told you already, will become internal hinge, danger, red color, internal hinge for conjugate beam. See, right here, this is internal hinge. Free end in real beam becomes fixed end in conjugate beam. Here, free end in real beam, fixed end in conjugate beam. Overhanging or interior support in real beam equal to internal hinge for conjugate beam. Simple support in real beam is simple support in conjugate beam. Now, next step is very important, calculation of reactions for conjugate beam. Now, very careful. Tell me, once you write correctly what all I tell now. See here. Once you see, this is simple support, just vertical reaction. This is fixed end, vertical reaction and reacting moment. Okay, here, all imagination, simple support, only vertical reaction, fixed end, vertical reaction, reacting moment. Simple support, only vertical reaction, don't see the value there. And fixed end, vertical reaction and reacting moment. You don't have to waste time finding all of them, because see, what to do is, this beam, once you see, you find the value of VA dash. This question, you find the value of VC dash right there. When you find conjugate beam reaction for conjugate beam, you find the reaction only at that simple support in conjugate beam. Do not waste time finding vertical reaction and reacting moment at fixed end, because once you get this reaction for conjugate beam, whatever you do, look this side, don't look that side. Do not look fixed end side. See, when you do any calculation for conjugate beam, look this side. So this question, remember, wherever you do, look, you make a note here. First question, wherever you do, look this side. First question, whatever you do, first question, look left side. So wherever you calculate, if you look left side, does this reaction required? Tell me. You can find it, not a big issue, but time should not be wasted. If, see, suppose I want slope and deflection, shear force bending moment. Wherever you are, look this side. Then this is required. This is required. This is required. This is not required, not required. Or here, wherever you are, this question, look right side. Wherever you are, look right side. If you look right side, this VC dash required, but this is not required, not required. Clear? So you find reaction only at that simple support of the conjugate beam. Never waste time finding reaction for fixed end of the conjugate beam. For this question, This type of question. Clear concept? Tell me. Is the concept clear? You have to write all those things. You have to tell, is the concept clear? Do not waste time. Sometime these all should naturally come to the mind. You are not answered. If the concept is clear, I will go further. I will tell you how to. Okay, now, very important. Do not take moment about A, because if you take moment about A, this will come. Do not take moment about B. If you take moment about B, VA dash will come. MB, see, this MC dash also will come. Or for this case, a special case, do one thing. To find the reaction at simple support of conjugate beam, apply what? The basic condition that bending moment at the point of internal hinge in conjugate beam equal to how much? Wherever you know, when at the point, this is a basic rule. See, internal hinge cannot resist bending moment. So, bending moment at the point of internal hinge is equal to how much? Bending moment is zero. Therefore, this question you apply bending moment at C0, look this side, get VA dash. This question you apply bending moment at B0, look that side and get VC dash. Clear? Write it 10 times if you want. This question, apply the condition BM at C0 for conjugate beam. Look this side, get VA dash. This question, apply BM at the point of internal hinge B in the conjugate beam 0. Look that side, get that reaction. Don't apply sigma M, sigma B. Once you get that one, remaining two reactions you can find by sigma M0, sigma V0. You don't require it. Clear? Okay, start. I wrote here now. See, now, calculation reaction at A. See, YA I told in the class. YA finding VA I told in the class. YC I told in the class just now. Okay, start. Bending moment is 0 here. Look this side. See, one more thing. Usually reactions you apply upward. But one thing, here loading is upward. Therefore, if you apply upward reaction, negative will come. Little common sense. When the loading is downward, reaction is upward. When the loading is upward, tell me how reaction will come. Instead of wasting time, you can take upward, negative will come, then you have to change it. So common sense. When the loading is this way, tell me, reaction will be up or down? Down. Therefore, consider reaction down, down. And this will rotate like this, balancing moment not required. Okay, start. BM at C0. Look this side. Not sigma M. Bending moment at C0. Only, I told 1,000 times, when it is bending moment, you have to look only one side. I have seen so many online classes, they tell, apply sigma M about C equal to 0. I will tell them, if you write sigma M about C0, it is algebraic sum of moment of all the forces about C. It is not, then why are you looking this side? Why you are looking this side? You should look that side also. They will tell, no, because only that side is 0. Who told? Then don't call sigma M 0. Call it bending moment 0. Once you use the term bending moment, then you have to look only one side. See, these are all elementary structural knowledge. Will come only if you thoroughly understand everything correctly. Then only possible. Okay, start. Here. Bending moment 0 here. Minus, y minus, bending moment. No clockwise, anti-clockwise. Bending moment. Minus VA dash into 5 plus half into 5 into 576 into moment about this point into 1/3 of 5 equal to 0, get me V A dash. Y 1/3, if I explain now, you should protest and walk out. You should tell, sir, you are wasting time. You are explaining, when you take moment about C, Y 1/3. You should tell, you are insulting us by telling that one. Answer, V A dash. I will tell you what V A dash should come using my trick. You don't worry about the trick. Calculator on. V A dash has to come 48 by EI. I have not seen anything. Sometimes people tell, sir, tell us, sir. No, leave it. 48 by EI should come. Answer. V A dash should come 48 by EI. It's answer. Substitute. Check the answer. V A dash has to come 48 by EI. Same. Thank you. Plus will come. I told you. Plus means what? Plus is not upward, downward. Plus means what direction you assumed is correct. 48 by EI. Go back and enter. But answer. 48 by EI. Remember, calculated value over. That's all. Never waste time for this reaction. Okay, come to this question. I will dictate here. You should write. Bending moment at B equal to 0, look that side. Minus VC dash into 10 plus half into 10 into 120 by EI into 1/3 of 10 equal to 0. You get the value of VC dash there. Okay, you get the value of VC dash. I will write the answer. See, I wrote, look that side. Just a couple 120. Okay. That reaction has to come 200 by EI. It will come, don't worry. It will come 200 by EI. Okay, now I will leave that question for you to complete. Okay, start. Now remember, make a note. We found for the conjugate beam left side reaction. Here we found for the conjugate beam right side reaction. Therefore, now when you continue this question, wherever you are, look what side? Look right side. This question, when you continue, whatever you do now, for this question, now onwards, look left side. Don't look right side. Clear? Warning. Now this question, whatever you do in conjugate beam, look left side. That question, whatever you do in conjugate beam, look right side. If clear, I will close the question. If clear, I will close the question. If the concept is clear, tell me. I will close the question now. Now nothing is there. Now simple calculation. First we will finish by conjugate beam method. Then I will tell the trick. Trick means I will rub everything. You are not telling, clear or not. Looking which side is also equally important. Everything clear? At least somebody should tell. Because that is one reason is I want to confirm that everything is clear. Second one is what? Voice problem, if it is there, I should know. Clear, thank you. I want to confirm that there is no voice problem. Once in a while, I check it. Okay, now, full I will remove. That question, answer I will give later. Okay. Start, one by one. What they want? First they want calculation of slopes at supports. Little rubbed out, I'll write once again. First they want calculation of slopes at supports for real beam, that is actual beam. Start. That is, they want theta A and theta B. See, original question. What is theta A? What is theta B? Start. Theta A clockwise in real beam equal to shear force. This I should not write now. You should tell, sir, why you are writing again and again. Theta A clockwise in real beam equal to shear force at A conjugate beam, left side up, right down. Slope here is shear force here, come slightly inside. Look that side, it is minus 48 by EI. Why? Left down is negative. Therefore, theta A equal to 48 by EI radian anti-clockwise. Then slope at B in real beam equal to shear force at C in conjugate beam. Look this side. It is minus 48 by EI, no into, plus half only load, plus half into 5 into 57.6 by EI. That's all. Tell the answer. Answer has to come double of this value. Answer. Why means I will tell you later. Answer has to come double of this value and what? Opposite sign should come. Answer. Answer has to come double of that value and opposite sign has to come. Plus 96 by EI. Therefore, theta B equal to 96 by EI radian clockwise. Clear? Now, next. So, I will do one thing now. I will write the answer here. What all you got? See, this is your original beam. Correct? You applied a UDL here. This is A, this is B, this is C. Just now you got theta A equal to 48 by EI anti-clockwise. Theta B you got 96 by EI clockwise. Then, now you are getting slope at C and deflection at C. Okay, start. Now, slope and deflection at the free end C. Cut. Slope at C in real beam equal to shear force at B. Oh, this is not B. Ayo, A. This is the point B actually. Ayo. See, by mistake, there is a confusion. Okay, I'll change it now. Sorry. It should not happen. 1 minute. This is B. By mistake, I wrote C here. This is B. This is C. Okay. Then BM at where 0? BM is 0, not at C, at B. By mistake. Oh, see, BM at B equal to 0. Clear? ABCD problem. BM at B equal to 0. Correct? Okay. ABCD problem. No problem. Clear now? ABCD problem. No problem. You can correct it. I wrote B there. By mistake, I wrote C here. Because habit. Why habit? Left hand is A, right hand is B. It is a habit. Okay, no problem. Okay, start. Now, theta, this is B. Okay, now I want what? Slope at C in real beam equal to shear force here. Don't look that side. Why? Actually, if you come slightly inside, this VC dash only shear force. No, because we don't know. Look this side. Start. Only force minus 48 by EI plus half into 5 into 57.6, half into 5 into 57.6 by EI, and also plus this load. How much? I told you this load is what? Parabolic part. I told you already how much? 1 by 3 of 2.4 into 57.6 by EI is the slope. Answer. Calculate and tell me the answer. Meanwhile, I will apply my own special tricks and get the answer. You don't do that way. I will apply my own special tricks and get the answer. Huh? What is this calculator? Nonsense. Plus how much it is? 48. Not 48, plus another 48. Slope at B is to 96. 96 plus 20 into 2.4 cube divided by 6. I got 142.08. Tell the answer. Okay, you are not getting same answer. So it is plus 142.08 by EI. Therefore, theta C equal to 142.08 by EI radian clockwise. I will enter the answer here. Why? For showing the trick for you. 142.08 by EI radian what? Clockwise. Okay, now next I'll remove all this one now. This I will remove. Next you want what? Next you want deflection at C, down in real beam equal to bending moment at C in conjugate beam sagging positive. Deflection here is bending moment here. Look that side. Start bending moment. No clockwise, anti-clockwise. Minus 48 by EI into 5 plus 2.4, 7.4, then plus half into 5 into 57.6 by EI is the total load into moment about this point. How much it is? Into 2.4 plus another 1/3 of 5. 1/3 of 5. Again plus red color parabola plus 1/3 of 2.4 into 57.6 by red color means formula EI into its center of gravity is here. This is 2.4. This distance is 3/4 of 2.4. This all explained for you endless times. Calculate the answer. I will apply my trick and calculate. You don't do those things. I will apply my own personal trick, not your trick. Got it? Got it? See how fast it can be done. Very simple. For your information, tell the answer. Answer fast. You are not given the answer. Okay. Answer 590.4 is wrong. 590.4 is wrong. I am sure it is wrong because I got some other answer. 590.4 is wrong because I got some other answer. By my shortcut. My personal shortcut. Not conjugate beam method. My personal shortcut. That is wrong. I got the answer here. See, I wrote in the paper to show you. Some rough paper I written it. Once you tell the correct answer, I will show it. Okay, Suresh SN got 313.344. See here. Can you see answer? Can you see the answer? What I wrote earlier, shortcut. Can you see the answer? Tell me. See, I wrote in a paper, some book was there. I wrote there big letters so that you can see it. Telling or not telling? Yes. Plus 313 point. 313. Forgot now. Ayo. I can see my book only. Why? 344 by EI. Therefore, presentation. Deflection at C equal to 313.344 by EI meter down. I will enter the answer here. 313.344 by EI, that much down, meter. Okay, that also over. Now, lastly what they want? One extra portion required. AB span, what is the deflection at center? Okay, I will remove this one now. Full I will remove. That question I will explain you. Oh, what happened there? I wrote the answer there, I rubbed. Okay, no problem. It was 96. Okay, this theta, this is B, this is A. Theta B is 96 by EI clockwise. Theta A is 48 by EI anti-clockwise. Okay, now lastly, to find slope and deflection at center of span AB. Span AB. That is, say, some name. I will call D. Okay. Now see, D is a new point. See what to do. Go back here. Light line without disturbing, mark D. I will use blue color, D. If it is 5 meter, this is 2.5 meter. Okay. Find bending moment at D for real beam, look this side, minus 11.52 into 2.5. What is the answer? Minus 11.52 into, see, by chance, if they, instead of center, if they give somewhere else, same procedure. Why I am doing center? Because trick is for center only. If they ask a 2 meter from here, that trick will not work out. My personal trick is always there. My own trick I don't require where. But that is ultra trick. So that standard trick will not apply. Answer. Minus 28.8 or 8. Now enter the requirement here. Come back here. You write, come back here. That point D, light line mark here. Enter that answer. 28.8 or see, actually not required, because when it is 57.6, center is half of that one. Waste of time, yes or no? If it is 57.6, this is half of that value. Directly you get it. Why you want to calculate? Clear? You don't have to calculate. Directly you can see there. Midpoint, half. Yes, okay. Now, if that is 28.8, light line, this value equal to 28.8 by EI, and without disturbing, this distance is 2.5 meter. Okay. Don't disturb other things. Start. Now, calculate. I want theta D and YD. Okay, start. Theta D clockwise in real beam equal to shear force at D in conjugate beam. Left up, right down, positive equal to slope here is shear force here. Look this side. Minus 48 by EI. Slope at D is actually not required. See, trick is not applicable to slope. Nobody will ask you, oh, I actually calculated. Actually, it is not required. Minus 48 by EI plus half into 2.5 into what? 28.8 by EI. Answer fast. Fast answer. Actually, for slope, actually for that also trick is there. That is ultra trick. Okay. Answer. I won't apply. This is not required for me. Tell the answer. Because I wrote, I want the answer. Because I wrote it, I want the answer. Minus 12 by EI. I put it. Minus 12 by EI. This is not objective question. Therefore, theta D is 12 by EI radian anti-clockwise. Okay, leave it now. This is not important. Start now. Lastly, important one. What? Deflection at D down in real beam equal to bending moment at D in conjugate beam. Deflection here is bending moment here. Look here. Minus 48 by EI into only 2.5 plus half into 2.5 into 28.8 by EI is the total load up to there into moment about this point of, or this is the point D, you have right light line here, only this triangle, 1/3 of 2.5. 1/3 of 2.5. Tell the answer. I will write the answer using my trick. I will write the answer using my trick. Ayyo, idu trick illa. Over. 90 by EI should come. 90 by EI should come. And very important, minus 90 by EI will come. Not plus, minus will come. Answer. Don't tell my answer. You got it? Just because I told 90 should come, don't tell my answer. You should calculate and tell. Have you calculated? Sometimes it happens. If I tell this answer should come, student will write without seeing anything. Did you calculate? Okay, got it. 90 by I. Therefore, deflection at D equal to 90 by EI meter, not downward. See, negative came upward. Lastly, at center here D, your deflection is 90 by EI meter upward is the result we got by conjugate beam method. Very important for compute examination. Okay, now, before giving the trick, shall I go to that question? Okay, 1 minute. That question, I will not give answer now. I will apply the trick for both the question in front of you. Then later, now later, theta B in real beam is shear force here. Theta here is shear force here. Slope is shear force here. Look this side. Deflection is bending moment here. Center here, shear slope, deflection equal to bending moment here. If it is 120, 60 will come here. Look that side. Tell me. This question, we will solve both the question by shortcut, which is very important for those who are preparing for competitive examination, especially GATE or little higher level. Simple PWD all, they may not give, but still sometimes they give. So therefore, very important for higher level. But sometimes in PWD I have seen giving, they expect it, but usually little higher level. Okay, I will start solving both the question, applying the trick. See correctly now. Now do one thing. I will apply the trick, get the answer for this question. We will check what answer already we got and give the answer for that question that you have to get after the class. Agreed? That question now you have to continue after the class. Clear? That question continue after the class. I won't write shear force, bending moment all there. And trick is very simple trick. Okay, agreed. Remember now, trick is very simple. Sorry. Completely remove this beam. Hey, go get out. Get out. Conjugate beam method, you get out. That also get out. I am not rubbing. Okay, get out. This all, nothing is there. See, this trick is applicable. Remember, it is a very popular question. They can give a beam, you write here now. The trick is a simply supported beam with overhang on one side. On one side. Any side will do. One side. Then load only in overhang. Only in overhang. That is, question possible is either this way or this way or this way or this way. Objective question. What all they will ask is, trick is for slopes at supports, then slope and deflection at free end, and also deflection y at the center of the span. See, what to do is, first you consider beam with the right side overhang. See now correctly. This is the original beam. No reaction, nothing. Upward, downward, all not required now. See, this is our beam. This is the loading given. I have given what? I have given UDL here. Later I will give homework for you when I give point load here. How much it is? Oh, I forgot the load only. How much? This is 5 meter. I still remember. This is 2.4 meter. I still remember. The load I forgot. I can do one thing. What is that? I can see the answer. See what load will produce that slope and deflection. I can solve that way. If you can tell the load. 20 kN per meter. Okay. 20 kN per meter. This question. See, UDL is there. Now, do one thing. Simultaneously solve second question. Second question. See, here UDL is there. They can give point load here. You can solve. I will give homework later. Second question is like this. There is a point load here. They can give UDL. Okay. A, B, C, D. Actually, see, I will put a name here. Name is not a problem. A, B, C. You write whatever name you want. A, B, C. Okay. Here point load is 30 kilonewton. This overhang is 4 meter. This is 10 meter. Okay. Do one thing. First what you do is, you only consider the member between support. That's all. What all I am telling you should write now. Consider only the member between support. Here also. Consider only the member between support. Nothing else. Don't see overhang. Okay. Here consider only what? AB. Here consider what? Only BC. This length is 5 meter. What all I tell you are right. This length is 10 meter. Whatever load on overhang is there, apply a couple. How much couple? Tell me. This couple is 20 into 2.4 into 2.4 by 2. That couple is called M. Tell the M answer. Here, if they give a point load into 2.4. Here, point load. Apply a couple M here. M. Tell me, this M, anybody can tell, 30 into 4 equal to 120 kilonewton meter. How? No plus minus. Here anti-clockwise, here clockwise. This is actually bending moment there only. How much answer? 57.6 kilonewton meter. Correct? Now do one thing. Okay. Now, if we apply the couple, sketch elastic curve for this member. Elastic curve. Tell me, this will hog or sag? This beam will hog or sag? Tell me, both the cases. When you apply a couple like this, whether this or that one, because of overhanging couple, beam will hog or sag? Beam will hog. So therefore, elastic curve, 5 meter, go that side. Go that side, elastic curve. Okay, beam will, little bigger. Beam will hog. Okay, here also, beam will hog. Both the cases, beam will hog. Here, beam will hog. Okay, hog. Draw the tangent to elastic curve here. This is the slope theta A. Draw a tangent to elastic curve. This is the slope theta B. Draw tangent to elastic curve. This is anti-clockwise here. Slope theta B. Draw tangent to elastic curve. This is slope theta C. Now you know that a simply supported beam, if we apply a couple M at one of the support, slope at the support where couple applied is what? ML by 3 EI. Other slope is ML by 6 EI. Here, where you apply the couple, slope is ML by 3 EI. Other slope is ML by 6 EI. Do you remember it? Tell me. And deflection at center is ML square by 16 EI. Deflection at center is ML square by 16 EI. Remember it? When a couple M is applied for a simply support beam at any one support, slope at the support where couple, these all already told earlier. You should go back. You should go back to old class, make a note and come back. Not simply right now. This is already over. I told you by words. Where you apply couple, slope is ML by 3 EI. Other side, lesser slope, ML by 6. Support where couple applied is high slope. Tell me, direct answer. You calculate and tell the direct answer. Start. You calculate. 57.6 into 5 divided by 6. Answer. Fast. You substitute. Why should I waste my time? M. 57.6 into 5 divided by 6. Answer. 48 by EI. Here. 57.6 into 5 divided by 3. Exam you find only what they want. They may ask you in exam. For the beam shown in figure, slope at A is, they'll give 4 options. One of the option is 48 by EI. Other options are wrong options. 96 by EI. Deflection. ML square by 16 EI. Deflection. ML square by 16 EI. 96 by EI. Now, come here. Tell the answer. This one. M is 120. 120 into 10 divided by 3 here. 120 into 10 divided by 6 here. 120 into 10 square by 16 here. Answer. This slope. 120 into 10 divided by 3. Answer. That is the answer you are getting for your next question. Clear now? This is the answer you are getting for your next question. Clear now? Answer. 120 into 120 into 10 divided by 3. Bega bega. 120 into 10 divided by 3. 400 by EI. Here, 120 into 10 divided by 6 EI. $200 by EI. Oh, see later. Slope here is shear force here. See, I got 200 by EI. Tell yes or no? Nodi, this VC dash is 200 by EI. Why? Slope here is shear force here. Tallying? Yes or no? Tallying or not tallying? Tallying or not tallying? But don't see there now. Tallying or not tallying? Deflection. 750 by EI. See, these all answer you have to get after the class for that question. Okay, now lastly what is pending? Now last pending. Now last pending is slope and deflection at free end. Nothing to worry. Last pending. Last pending. Slope and deflection at free end. That is here theta C Allah, theta A and what? Theta A and YA. Here theta C and YC. Now before that one, let us check the answer first of all. Let us check the answer. This is the result we got by conjugate beam method. Oh, good. That question. Tally. I am telling. Tally. Over. Now last, see. What you have to do is, some trick you have to do now. See. Now, see. What you have to do is, see. If you apply a couple here, this is the overhang. Correct? See correctly what I am doing. This is the overhang. Tell me yes or no. Overhang. Overhang is this side here. This is the point C. This is the point A. Correct? That is the overhang of length 2.4 meter. This is a overhang of length 4 meter. This is the point B. Correct? Yes. Now, this is the bending only due to what? Couple. That load effect is transferred here. So, if you don't consider UDL, see, actually beam will have curvature. It will have curvature here with the slope. But one thing, what you do? This elastic curve what you got, see now. What you do is, tell me, in case that UDL is not there, if only couple is there, tell me this portion, if when the beam bends here, this portion will be what? Curvature or straight? Don't see UDL there. Because of the bending of this couple, see, this will bend this way. That portion will be straight or curvature. If the loading is not, only couple is there, that right overhang is straight or curvature. That overhang is straight or curvature. Fast. That overhang portion will have straight one. So do one thing. That overhang will go straight like this. This overhang, see, same tangent will come this way. Then, is this slope is same as this slope? Tell me. 96 by EI. And is this slope same as that slope? Tell me, yes or no? Are the slopes equal or not? Straight line. Fast. Are the slopes same as that one? If there is no UDL, only couple is there. Yes. And this deflection will be what? This slope theta b into 2.4. This deflection equal to the slope theta b into 2.4. This slope equal to same the slope here theta b into what? Into 4 meter. Theta b correct? Yes, correct. Okay. Tell the answer here. Theta b is 96 by L to 96 by L to theta b 96 by EI into 2.4. Answer. Because why? You know it. If it goes this way, this deflection is the slope into distance. How much? You should write. The deflection here is straight line, slope into distance. Answer. First, this answer. (230.4 by EI). 230.4 by EI. This deflection, how much? 400 into 4. Ayo, calculate yakbekadke. 1600. Is it 1600 by EI? Second one, is it 1600 by EI? Yes. Now, this is the elastic curve if there is no UDL, if a couple is there, but UDL is there. Now, when the member bends here, that slope accounted. Therefore, now here, again slope should not come. Why? Whatever slope comes here is already accounted. Now, this will become a cantilever beam with UDL. This will become a cantilever beam with point load. So now the deflection is this way and this way. So now this slope equal to what? WL cube by 6EI. This deflection equal to WL power 4 by 8 EI. L equal to 2.4 meter. And this slope equal to anti-clockwise slope. For point load, WL square by 2EI. This deflection is WL cube by 3EI. Tell the answer here. W is how much? 20 into 2.4 cube by 6. Answer. Extra slope due to cantilever bending. Slope, now there is no, see, whatever slope is there accounted. Now zero slope. Zero, because why? No more further slope. Therefore cantilever. 20 into 2.4 cube by 6. Answer. 20 into 2.4 cube by 6. Don't give wrong answer. 46.08. 46.08 by EI. Tell this deflection. 20 into 2.4 power 4 by 8. Why? Cantilever deflection. 20 into 2.4 power 4 by 8. 20 into 82.944. Okay. 82.944. Okay. Here, answer. This dip slope. How much slope? Slope here. Point load. 30 into 4 square by 3 by 2. 30 into 4 square by 2 is the slope there. That question. 30 into 4 square by 2. Over question. One more calculation. Over. 30 into 4 square by 2 there. Bega. You tell fast, I get it will break. 240 by EI. And this deflection. 30 into 4 cube by 3. Point load deflection. 30 into 4 cube by 3. 30 into 4 cube by 3. 640 by EI. Agoit. 640 by EI. Now, for our first question, final theta at C, free end, at the free end, A, free end C, at the second question, what is one? Oh, the second question. For our first question, final at free end, final answer at free end, that is C. Theta C, final deflection C. See here. Because of the couple, it rotates by 96 by EI clockwise. Plus, because of the cantilever effect, rotates by 46.08 clockwise. Tell the answer. 96 by EI plus 46.08 by EI. 96 by EI plus 46.08 by EI. You add the slope due to what slope it gets because of the span bending, then how much is the further slope due to cantilever bending? Answer. 142.08. Abba, thank you. Just for fun, answer not coming means my theory is wrong. I would not have taken one more class from today. Final deflection, 230.4 here, plus there extra of 82.944. Tell the answer. By I am not wasting time. 230.4 and another 82.944. Same answer. People are lazy. They don't give the answer. 313.344 by EI. And for second question, tell the answer. For second question, final answer at which point? At A, free and A. Tell the answer. Final free and A, theta A and YA. Fast answer. 400 plus 240. Ayo. 400 is the slope, original slope here, plus 240 extra. 640, yeah? 640 by EI, yeah? Correct? 640 by EI, correct? Is it 640 by EI? Final deflection. It is 1600 plus 640. You write. By trick. 1600 plus 640. Same answer you will get by conjugate beam method. Lastly, I will tell the trick how you can do fast. 1 minute. Those who understand, understand it. 2240 by EI. Over. Now tricks are over. Now can you solve this question and check the answer? Tell me. Now can you solve that question and check the answer? Fast. Now can you solve the question and find the answer? Yes. Now do one thing. Before I conclude, I will tell the trick in the exam. Some will tell, sir, this much you are right. You don't have to write. Take your calculator. I will tell the trick now by words. I will dictate. I won't look at the board. I look towards you. You after the class, slowly you write it. I will tell it fast. Directly take your calculator in objective questions. Simply supported beam, one side overhang given. Suppose you first find what is the couple at the overhanging support. Say M. Here, 20 into 2.4 into 2.4 by 2. Here, 30 into 4. That couple is M. Remove the overhang. Now, find slope at both supports. Where couple is there, slope ML by 3 EI, other side slope ML by 6 EI. And if they want deflection at center, ML square by 16 EI. Over. If that is required, question over, go to next question. Clear? If that's any one of that is required, question over, go to next question. Clear? Okay. Now, by chance they ask slope or deflection at the free end. No problem. You already got a slope at the overhanging support. Slope at the free end equal to the slope at the overhanging support you got just now by couple plus extra cantilever slope. Extra that ML by 3I whatever you got plus extra, if it is point load, WL square by 2, if it is UDL, WL power 4 by what? WL cube by 6. Find the slope. Suppose there is deflection there. Then whatever slope you got at the overhang support, multiply by the overhang. That will give the shift of the overhang. Multiply the slope at the overhanging support with the overhang. Then add deflection for cantilever. Point load, WL cube by 3EI, UDL, WL power 4 by 8EI. That's all trick. So it requires just half minute to find any one of that one. Support if they want, not half minute, quarter minute. If they want a free end, half minute. Is the trick clear? At least. Is the trick clear? Reasonably clear? I dictated, you go to the statement again and again and write it. Okay. Trick useful? Trick is useful. Those, see, very popular for competitive examination. See, I have seen one PW exam they given. W, they told this is 2L, this is L. What is the deflection here? Answer, deflection there equal to WL into what? 2L, W couple, WL is the couple into 2L divided by 3EI into L plus WL cube by 3EI over. That's all. That's all. Etodbeku. Not even 15 seconds, 5 seconds or 10 seconds. Okay. But you should understand the principle, then only you can master such questions. Okay. So, but now don't ask me what is your ultra special trick. That is something else. That is mixing of all the methods. Because fortunately, I have no confusion about any method. I don't require personal note or remember this one, look that side, look this side, when reaction down or up, that's all no problem for me. Fortunately, no problem. Okay, thank you. We will meet next class with a new part. Further time I won't waste because if other full loading given, it will take lot of time, not worth. Okay, thank you. We will meet next week with a new chapter. That is columns and struts. Very powerful chapter, remember. In strength of material, very, very powerful chapter. Why? Tell me. Column and struts, what you cover in strength of material is the fundamental for RCC columns and steel columns. So, when you go to RCC or steel, people will tell you, you know all these things in strength of materials. People will tell, yes, I know. Unfortunately, who tell no, 99% of them are not knowing. That's all. Only 1%. They will tell pi square EI by L square. What is that one? Buckling load. Principle. Formula. They will tell formula. Principle. Sir, formula. Okay, very good. Okay, thank you.